Okay, so today we're going to be talking about joints, sort of what's up with them, how we can be using them. We're going to give a very basic overview of what joints are, what joint orientation is and why that matters, how to affect joint orientation, and how we can deal with some of the issues like gimbal lock that might be coming from joint orientation. So let's get started. So the way Maya is set up, you can access the Create Joints tool a couple of different ways. You want to be changing your tabs up here to rigging. The other is going up to your shelf and going from modeling to rigging, up to skeleton, create joints. So I'm going to go ahead and choose the Create Joint tool. I'm going to double click on it to open its options, which to access this menu of options, you can also go to skeleton, create joints, over to the little box. So I'm going to create some joints here, and then I'm going to explain what happened based off of some of the different parameters here in the tool settings. So I'm just going to go into the viewport. I'm going to hold X on my keyboard and click a couple of different places, and this will create joints that snap to the grid. And actually, I'll put one else up here just in case. So the first thing to note when we are creating our joints is sort of these orientation settings here. Each of these joints has a local axis that's not tied to the world. It's tied to the object that's made. And with these orientation settings, this chooses how we can choose how to orient our axes depending on what we're working on, right? Let's see here. There's also different things like degrees of freedom or symmetry. So if you're creating a skeletal body, you can turn this on and maybe like across the x-axis create different bones. So stuff like that. But we're going to ignore that for now. Talking about the orientation. In this case, our primary axis that the bones would be pointing down towards would be x, and they would also be using the y as a secondary axis, and it orients itself to the y plus or positive, or basically the up direction in the world. And also when you're creating bones, you can change the size of the joints and how they draw in Maya. And there are also different ways to do that, which we'll go over in a moment. But for now, let's sort of take a look at what's going on with bones. So the first thing that you might notice is I've still kept my tool menu open, and I wanted to show off the axis orientation, which may affect how you can manipulate your bones. And again, this is something super important to hold on to in terms of our orientation for joints. So let's change this to what you might have initially, which is setting the axis orientation to world. So we come in here just a little bit and take a look at my rotation manipulator. It's with the world, basically. So the axis is oriented to the entire world in Maya. So X is up against the X lines on the grid, Z is up against with the Z lines on the grid, Y is still up and down, but in this case, this is oriented to just the world. So it's not pointing down in the direction of my bone, so I can manipulate my bone, but it doesn't adjust with my bone, and immediately I'm going to have some difficulty dealing with it precisely. So I'll step back and see how we can fix that and give you something to be cognizant of when you're rotating your bones. I will change it from world instead to object. Now you'll notice that the z-axis is now pointing down. So I can rotate my bones a lot more precisely, and if you'll notice, my manipulator will stay with the bones. See, when we have our axis oriented towards object, it changes per the selection of the object that we're working with. And this is quite useful for us because it helps us keep our rotations clean, and it keeps it relative to our transformations. And in doing so, we're able to more precisely manipulate our bones, and we're able to also move these axes individually on their own without getting sort of junk data along with them. So I'll step back here just to get this back in position. And another thing that I want to note that you might have noticed when we created our joints is looking over here in the outliner, and I hold shift and left click, I actually have a whole hierarchy going on here. So as we were making our joints, Maya automatically created a parent-child relationship in a hierarchy for us. And this is very important to note that depending on how you have it set up, that your hierarchy may or may not be oriented how you would like, because Maya is doing the work for you. But in classic hierarchy fashion, of course, if I grab the parent and rotate it, it affects all the children. If I jump down to the third joint, I can rotate it and will affect the children without affecting the parent above it. And of course, this is the nice stair-step daisy chain pattern that I'm looking for in clean hierarchies that will allow us to very specifically define our skeletons once we begin laying out skeletons and keep things organized that way. So I'll step back again here. So let's talk about making things a little more accessible in your viewport. So let's say that right now this is way too small for my liking, and I want the bone to get bigger. So I'll go over here to grab my scale tool, and I'll just try and blow it on up. That's not what I'm looking for. See, the actual joint itself here in the bone did not get any bigger, but the bone that is drawn between the parent and the child did. If we go over here, you'll see that the scale value has also changed. Now, this can be useful if you want characters to get skinny or to bloat or control their scale in a different way, but generally speaking, this is not an attribute you want to alter when you're using bones to animate a character in rigging. So I'll undo here and talk about a different way to choose this draw size in the viewport, so we can sort of organize ourselves a little bit better. And that's with the radius attribute over here. So I can go in and key in whatever I want to make it even smaller or make it much, much bigger. Point being is that this joint is more of a visual indicator than it is a physical object in Maya. Of course, it occupies a spot in space and has attributes, but this little ball that we see around here is more for our eyes only. We won't be seeing it in the final result for most renders. So let's step back again. You can also access this radius from the attribute editor. If you go down here under the joint tab, you can also find it and resize it. There's also something to note here is the draw style. So you can basically hide this without using the H key if you have different ways that you want to nest and hide your skeleton away from animators so they can't touch it. So I'll undo again. And again, a use for this might be, say, here I'll make some new joints. Let's just say, this is happening because I still have symmetry on. So let me undo there. I'll double click this to enter. I'll change symmetry from the x-axis to off. And just to make sure, I'll hit reset tool. Everything else is as it should be. These default settings are fine for a lot of what we're going to be doing. So we'll go ahead and try that again. So I'm going to make a handful of just very, very close joints. Let's say this is a finger or a tail on a tiny mouse. So let's say I want to get in here, right? And I'm trying to grab these different joints, but I'm having difficulty finding the single one that I want because all the others are in the way. Well, there's an easy solution to this. You can simply highlight them all in our outliner and go over to the attribute editor and key in a smaller value. Now these are a lot easier to grab, to manipulate, to pick out one by one in a very specific situation. So if we're working like on a small creature, or for whatever reason our scale has changed, you can use this method to change the draw size of the bone in the viewport. So I'll delete this for now, and we'll now discuss something called joint orientation. So again, jumping back into our joint tool, the way the joint is oriented, as I mentioned before, is along this primary axis, X. And X's are red in Maya, if you'll notice. So what I want to do is grab just this and zoom in. I'll close this for now as well, but zoom in. And if you'll notice, once we select this, there's a tiny little axis along in here. Well, that's because of how we set our axis orientation. The x-axis, which is red, is pointing towards our next bone. Same deal here. The x-axis, the red line, is pointing towards our next bone, all the way down the daisy chain to the very end of the hierarchy. Now, notice that this one isn't pointing in the right direction, and there's a reason for that, it being joint orientation, and we can do some things to fix this later. So, why does joint orientation matter? Let's see here. Well, instead of rotating these to manipulate the bones, like one usually should when animating, let's go ahead and move these, right? So I'll take the move tool and scoot it down in space, and even do that over even further down the bone. So completely mess it up. Now you see if I select this, my little axis is still pointing where the old bone was, but since I didn't rotate it, now the joint is oriented improperly. And now along the lines of this axis orientation being set to object, now it's just kind of off, right? You can see in here especially that this angle is not flush. It's not pointing down the correct way. So an issue we might deal with here is having the inability to move our bones precisely with the rotation manipulator. So I'll step back here, just bring this down. And same deal here, right? It's way off. So there's no way that I'd be able to rotate this accurately. So if I wanted to go straight up and down along this line, begin to rotate it, well, the rotation's fine, but it's not going relative to the bone as it points towards its children. So again, this orientation being off can cause a real pain and a real hassle for not only us as riggers, but animators as well. So I'll undo a little bit here. Let's see here. Is this still broken? Actually, I'll step forward. Maybe not. So I'll break this again. So how do we go about fixing this, right? Like, this isn't pointing where it needs to be. So if I want to rotate this and manipulate it, I'm going to have a really hard time getting that to work in a way that I would appreciate. Well, if we go over to our attribute editor with one of our joints selected in the hierarchy over here, and we scroll down just a little bit, you can see joint orient. So this angle has been set by Maya when we had our preferred joint orientation angled out, and managed to basically put in this value for us. So it was, before I messed it up, pointing at the bone. So I can go in here and alter this value manually and see how everything begins to change. Same deal here. Here, I'll even mess this up again. So our orientation is off. And again, we can try and dial it in. It'll affect the orientation, but we can try and fix how this works by keying it in manually, which we can try to do. This is generally speaking sort of one of the last resorts, and we'll go over another sort of last resort to fix this. But if you want to try and change this joint orient to fix it, or even try and hit this rotation axis, you can get some different results, but again, it's not quite what we're looking for. So let's see if there's a different way to try and fix this, right? So instead, what I'll do is I will go into what is called component selection mode. And in doing so, we can basically select this little axis over here and figure out the correct way to get it pointing. Now, before we do so, I'll probably make this a little easier on this so we can actually see what we're working with. In doing so, I'll just highlight the whole hierarchy so I can select all of this and turn on a visibility option for all of my bones. I'll instead go up to Display, Transform Display, Local Rotation Axes. So now we can see those little axes without even having to select this. And they've been nicely labeled by Maya for us so we can get an idea of where it's going. And again, completely wrong. None of these bones are pointing in the direction that I want them to be. So we'll use the component selection tools to try and rectify that by hand. So what I'll do is I'll go ahead and have this selected. I'll go up to the top here and go from object type selection to component type selection. I'll do that. And if you're missing some menus over here, because we're going to need this button over here, you might just need to expand it. Same sort of deal over here. So I'll expand this menu, this one. Then I'll choose the question mark, basically allowing us to grab miscellaneous components, which this little axis in the bone is a miscellaneous component. So I can grab it, hit R for my rotate, or hit E for my rotate tool, and now I can manually change it. And if you'll notice, if you're paying attention over here, not only is my joint orient value changing, but my rotate axis value is changing as well. So now I can try and square this up so this is oriented much closer to where it needs to be. I'll do the same down here. And do the same down here. So we can use this tool to sort of eyeball it, right? To get an idea of where it's pointing down. So now if I switch back to object selection, and with my rotate tool already selected, we can see that my axis and the way it's oriented is once again in line with the bone. Not perfect, mind you. You can see it especially here, and we'll see how to fix that in a minute. But this is another way that you can try and eyeball a solution. So if you're running out of options and some of the automated solutions to this are not working, you can try and use the component selection up here with the miscellaneous components selection enabled to try and rotate those by hand manually. And again, something to notice here is that the rotation data is held in rotate axis and joint orient. It's not up here in rotate. And that's what we want, right? We don't want our rotations with any extra junk data in them. We want the junk data held deeper where the animator cannot access them. And in doing so, we're able to keep these clean values and we're able to reset them just by keying in 0 and make it easier for whoever might be using our rig later on. But while that was a decent solution using the component selection, it's not a perfect one. So let's look at something that can be a lot more useful. I will give you a tool, I will give you a script later in class to do an even better job than Maya, but I'm going to show you how to manually do this through Maya just in case you find yourself without the script. So I'm going to select all of these, and I'm going to go up to Skeleton, Orient Joint, but over to the box first. Because if I grab this over here, this menu should look familiar. It's a lot like our Create Joint tool where you can reorient the joints, except we can basically have Maya do it for us after we've made them. Now I'll reset my tool because my settings probably aren't the same as yours. So we can basically tell Maya to aim X down the primary axis, and then of course have our Y's be our secondary axis oriented upwards in the world. If you'll notice here, there's also a big button called Toggle Local Axes Visibility. And you can do that same thing that I was talking about earlier, showing the labels for these axes so you can see them without having to select them. And honestly, I might use this button a little more because I can have this window stay open and I don't have to use the transform display instead. It's just a little bit faster. But now we'll go ahead and use this tool to actually orient our joints. So with all of them selected, they're white here in the viewport, I'll hit Orient. The biggest change you could see immediately was back in this one. I'll do it just again to demonstrate. So it's scooted over. It's now mathematically pointed over there. Notably enough, our rotate axis is clear, but our joints orient is holding that data. If we go through and click, that junk data that we were seeing in the rotate axis also has been erased. So that's another way we can clean up our transforms and have some of these some of this junk data for our joint orientation held in one spot, keeping all of our other transforms and attributes clean. And lastly, we can take a look at how to orient this joint properly. It's very similar to the same methods that we were using. So the end joint in a hierarchy doesn't have a bone to point at, right? So Maya doesn't know how to orient it through our normal settings, but it's a pretty easy fix. You just go up to Skeleton, Orient Joint, and we're going to open the box again. And we're just going to tell Maya to orient the joints to the world instead. When I hit apply, now you can see my joint is oriented in line with the bone before it instead of the bones after it. So you only want to use this option for the end of a joint chain. So I try to leave this unchecked in case I leave it and only turn it on and off for a very specific use. Okay, so that's a pretty decent overview of how to orient your joints and how to create them in Maya. We'll of course be using these in a much more advanced way as we go through our class. But for now, I'm going to go ahead and hide this visibility on these local axes. And now I'm going to show off Gimbal Lock. So Gimbal Lock is an issue that you cannot avoid, but you can be cognizant of and be prepared to deal with as you plan your rig. Basically, what this means is that there's a point where all the axes for your joints orientation, for your joints rotation, will converge. And once they converge, they can't sort of be pulled apart from each other, and one axis might affect the other. And it creates a strange effect. You don't necessarily have to do this, but I want you to at least watch so you know what to look for and understand what Gimbal Lock is. So I'm just going to go up here and change my rotate settings from object to gimbal. My manipulator changed a little bit here. If we rotate along our y-axis, you can see there will be a point where my x and my z end up sort of fighting each other and are in conflict in the same spot. So I'll switch back to object. It looks fine though, right? Move it up and down. Seems to do that. Try to twist it. All right. Left, right. Seems to work. But let's see what happens now if we set a keyframe. So I'll hit S here, scroll forward in time, and tilt this down. I have auto keys on. That's this button over here, so Maya will fill it out for me. Now, let's see what happens if we try to play this back and look. Well, that's not exactly what I want. Well, I rotated it in Maya just down this way. Why isn't it going down this way? Well, this is what Gimbal Lock looks like. This can be an issue, especially if you're an animator. You will have difficulty getting a realistic motion if it swoops to the side in this sort of like U fashion or this non-linear shape, right? Because you can see it's still going from point A to point B like we asked, but as opposed to following it just along the Z-axis, because those two transform axes are in conflict, it's basically trying to compensate for that by creating this strange sort of swoop out shape while it gets from point A to point B between our keys. That interpolation is just strange. So again, this is an issue that will just end up coming against if you're an animator, but the whole point is that you maybe want to plan your joints and plan your skeleton layout around the idea of Gimbal Lock and figure out if there's a way that you can deal with this and lay out your joints in a smart way so that the animators or yourself as you test the rig don't come into conflict with Gimbal Lock. So if you plan it properly, you can. But this is sort of comes with the nature of how Maya evaluates things and interpolates them. So once you get to this point, it's difficult to avoid it. You can just find ways to mitigate it or basically not take the same actions that would lead you there. So I'll undo my keyframes and show how we can sort of deal with this and at least plan for it. I'll go ahead and go back to this. I'll go back to Gimbal. It's not an exact science for this demonstration, but I'll try and get this. Let's say back to 0. And pop back into our object orientation just in case. So actually I do want Gimbal so I can show what's going on here. So I'll switch back to Gimbal and I'll bring open my attribute editor to see what we can do to fight this Gimbal Lock. Well, in order to do so, there's a lovely little menu over here on the right called Rotation Order. Rotation Order allows us to basically pick and choose how and where our Gimbal Lock happens. From this menu, the best way to think about this would be is that the letter in the middle of your rotate order is what you have to rotate along to get to Gimbal Lock. So Y is green in Maya. So again, if I rotate along the Y-axis, I will eventually run into Gimbal Lock along there. If I change this to ZYX, the reverse, same deal, right? Except Z instead will rotate. Go ZXY. If I rotate along X, now it'll come into conflict there. YZX, if I rotate along Z, that's where I'll hit my Gimbal Lock. So the point of this is that depending on the motion of your bone, you can change this rotation order to help your animators mitigate Gimbal Lock. Because if this rotation order is along axes that you're not going to rotate along, then the animator will never run into Gimbal Lock. A good example for this would be like perhaps a shoulder object. So I'm going up here. I know my shoulder will go up and down, right? But it won't go all the way around because then I'd start breaking myself. It might come out left and right as you swoop your shoulders that way, or it might twist a little bit. But I know when it comes up, it's not going to go all the way around up. So it might help to put my rotation order along that axis to ensure that we don't run into Gimbal Lock. And again, you can't avoid Gimbal Lock completely. You can do your best to mitigate it, but it is a shared responsibility between both the riggers and the animators to make sure that the rig is planned out in a way that avoids Gimbal Lock as much as possible. So think about planning your rotations on different parts of your body or different parts of the skeleton as you begin to lay out your joints And think about how you can do that to mitigate gimbal lock. So in review, we're going over joints. You're able to create joints with the joint tool. Space, you can snap them to the grid, all that good stuff. You can also drag it into the hierarchy to parent it up. But now its joint orientation is a little off, so you can use tools like the Orient Joint tool to fix those. You can also fix that joint orientation by trying to eyeball it. You can grab it, go into component mode with your miscellaneous button selected. You can use that to rotate these and fix this orientation. You can use the Orient tool like I was talking about earlier and use that to rectify and correct your joint orientation. And again, this matters so that our manipulators, which we have set to object instead of world, we have that so our manipulators here can stay clean and along the bone. So when it comes time for us to either pose our rig or pass it off to animators, that remains clean, easy to understand, no extraneous values here, and all that good stuff. And again, the junk value is held down here in Joint Orient. It's not held up in our rotation. So if we need to zero these out to return them to its initial position, we're able to do so correctly and easily. And that concludes the overview of joints. So as of always, we'll be applying this in depth the more we get through class, but please feel free to ask me any questions if you have those.